In this video, we take a look at using some examples that involve ions. In our first example, we're going to be using the ammonium ion, and the ammonium ion is NH4+. So if we're counting up the valence electrons, nitrogen is in group 5, hydrogen's in group 1, but there are 4 of those, and then we'll have to account for the charge of +1. So we have, not accounting for the charge, we have 9 electrons. Now the +1 means that there's an electron that's been lost, and so I'll subtract 1 for that, and that gives us 8 total valence electrons. We place nitrogen in the center, and let's connect that to the hydrogens. By connecting it to the hydrogens, we'll have to have 4 bonds, and that'll use up the remaining 8 electrons. The hydrogens do not need to obey the octet rule, since they only need to be surrounded by 2 valence electrons, and the 1 bond already satisfies that. We'll also double check and look at the central atom, nitrogen. It should have an octet, and the 4 bonds does provide it with an octet. So this one is finished, except it's kind of unclear to the reader that this is an ion. So what we're going to do is we're going to surround the whole structure in brackets and put the charge outside. So to review, we have a couple different things to worry about when we're doing a Lewis structure that involves ions. One is that we're going to have to make an adjustment for the charge. When we have a positive charge, we subtract electrons, and when we have a negative charge, it means that there's additional electrons have been added. So that's going to affect the sum of the valence electrons right at the beginning. There's also one last thing that you have to worry about right at the end, which is that the entire structure needs to be put into brackets and the charge outside, and this will be a clear heads up to your reader that this is an ion, and that way you won't be confusing your reader. Now let's erase what we have so far so we can take a look at another example. And for our last example, we're going to be doing the cyanide ion. The cyanide ion is Cn-1. So let's count up the valence electrons. Carbon's in group 4, nitrogen is in group 5. That gives us 9 electrons. But the charge of -1 is going to have us add 1 more electron, so that gives us 10 electrons total. There really is no central atom. We're just going to put the carbon and nitrogen side by side, and that 1 bond is going to use up 2 electrons out of our 10. That'll leave us with 8 electrons remaining. Now, in order to distribute the electrons around here, we're going to start on one side, and let's just start on the carbon side. So I'll put 6 electrons around there. There are only 2 electrons left over after that, and those 2 electrons we're going to put on nitrogen. Now, this is not very fair to the nitrogen because nitrogen is only surrounded by 4 valence electrons, and we need to get that up to 8. And so here we'll have to do some multiple bonds. So let's take care and let's erase some of the electrons that are on the carbon, and since we have to do 2 double bonds, I erase 2 pairs of electrons, and so that will give us a triple bond between the carbon and the nitrogen. Our last step is to put the whole structure in brackets and put the charge outside.